Our universe is constantly expanding, making it incredibly challenging to define its boundaries or measure its true size. But thanks to the incredible capabilities of the James Webb Space Telescope, we are now able to peer deeper into the farthest corners of the cosmos, bringing us closer to answering some of humanity's biggest questions. This telescope has opened up new frontiers of knowledge, revealing the vastness and complexity of the universe like never before. Since the telescope's mission began, renowned scientists such as Brian Cox have made groundbreaking discoveries that have shocked the scientific community. Their announcements about the true scale of the universe are staggering and almost beyond comprehension. The more we learn, the more we realize how small we are in the grand cosmic scheme. But this knowledge also invites us to reflect on our place in this immense, ever-expanding expanse. Within the portion of the universe that we can currently observe, scientists estimate that there are around 2 trillion galaxies, and this number is based on the study of just our local universe. The truth is, what we can see with our most advanced technology is likely just a small fraction of the universe, which could very well be infinite, a concept that challenges our understanding of space and time itself. We are only beginning to scratch the surface. One thing is certain: we are not separate from the universe, we are in fact a part of it. The universe knows itself through us. It is almost as if we are an expression of the universe existing in a relationship with the cosmos itself. With the power of the James Webb Space Telescope, we are able to delve deeper into this cosmic mystery, pushing the boundaries of what we thought was possible and seeking to uncover the true scale of our existence. If you're fascinated by the mysteries of the universe and want to stay updated on the latest discoveries, make sure to subscribe to our channel, hit that like button, and turn on notifications so you never miss an exciting new video about the cosmos. Now, let's take a moment to think about scale in a way that brings it closer to home. Imagine you're traveling at a speed of 70 miles per hour. If you were to travel at that speed for 24 hours a day, it would take you about 15 days to complete one full lap around the Earth's equator. That's quite the journey, right? But what about traveling to the moon? At that speed, it would take you roughly 5 months to get there, and reaching Mars at its closest point would take you a mind-boggling 63 years. But if you wanted to travel to Neptune, one of the farthest planets in our solar system, it would take you an astonishing 4,400 years. These numbers may sound unbelievable, but they demonstrate the sheer scale of our solar system. To make this even more tangible, let's consider the journey of Voyager 1, the most distant spacecraft ever launched by humanity. Launched in 1977 at a speed of 38,000 miles per hour, it took Voyager 1 a staggering 35 years just to exit our solar system, finally reaching the edge in 2012. Even light, which can circle the Earth 7 times in a single second, seems relatively slow when we consider the enormous distances involved in space travel. But even though our solar system is vast, it's nothing compared to the size of our Milky Way galaxy, which is one of billions of galaxies scattered throughout the universe. The Milky Way contains around 300 billion stars, and each one of those stars likely has its own planetary system. If we look at our closest neighboring star, Alpha Centauri, it's located about 4.3 light years away. Traveling at the speed of light, it would still take us 4.3 years to reach Alpha Centauri. To truly grasp how immense that distance is, imagine traveling at the same speed as Voyager 1, which is 38,000 miles per hour. Even at that incredible pace, it would take a staggering 70,000 years to reach Alpha Centauri. This shows just how vast the distances are when it comes to exploring even the nearest stars. The scale of the universe is both mind-boggling and awe-inspiring. Now let's focus on a star called Rho, located 64 light years away from us. In our own universe, we've been sending out radio signals for over a century now, and those signals have reached about 15,000 star systems. These signals, however, have weakened as they travel further. What's incredible though, is that they've covered such immense distances across space. In comparison, the number of stars we can see with the naked eye is a mere fraction of what is actually out there. To put it in perspective, the signals from our radiosphere or reach in space are just a tiny dot within the immense vastness of the Milky Way. But here's something truly fascinating. If you look at Rho in the night sky tonight, you're actually looking at light that left the surface of that star around 640 years ago, right around the time when Columbus was preparing to sail to the New World. The light from Rho has been traveling across space for centuries, and it's only now reaching us. This is the beauty of the cosmos. Time moves differently when we look to the stars. Now let's zoom out and consider the Milky Way galaxy as a whole. Imagine we reduce our entire solar system to the size of a quarter. The entire Milky Way galaxy would span the width of the United States. Within this massive region, there are 300 billion star systems, each potentially hosting their own planets. We are just one of those star systems floating in the middle of an unimaginably large number of stars and planets. But our Milky Way is just one galaxy. There are at least a trillion more galaxies in the observable universe. Yes, a trillion, an unfathomably huge number. To help put this in perspective, imagine a collection of 1000 cats. Then, imagine that there are 1000 groups of 1000 cats. That gives us 1 million cats. But a trillion is a million times a million, an absolutely staggering number. Our nearest galactic neighbor is the Andromeda Galaxy, located about 2.5 million light years away. Andromeda is not only approaching us, it's moving at an incredible speed. When it eventually collides with our Milky Way galaxy, the two will merge. Andromeda contains around 1 trillion stars, while the Milky Way has about 300 billion stars. While the chances of individual stars from both galaxies colliding are very slim due to the vast distances between them, the collision of these two galaxies will dramatically alter the structure of our cosmic neighborhood. As we continue to zoom out, we find that our Milky Way is just a small part of the local group of galaxies. Beyond that, we encounter the Virgo cluster, home to over 1,500 galaxies. And this cluster is just one piece of the much larger Laniakea supercluster, which contains about 100,000 galaxies. Each of these galaxies is home to hundreds of billions of stars and planets. But even Laniakea is just a small slice of the observable universe. There are 10 million superclusters in total, each containing hundreds of billions of galaxies. These superclusters form a vast cosmic web stretching across the universe, interlinked by filaments of gas, dust, and dark matter. This cosmic web is a structure that binds the universe together, and it extends across billions of light years. And as we venture further, we encounter even more extraordinary phenomena. Supernovae, for example, are the explosive deaths of massive stars, scattering heavy elements across the universe and enriching the interstellar medium.
Black holes, with their immense gravitational pull, shape the evolution of galaxies and can even release powerful jets of energy that stretch across vast distances.
We also find quasars, which are supermassive black holes at the center of distant galaxies that emit enormous amounts of energy, acting as beacons of light from the early universe, giving us a glimpse into the cosmos as it was billions of years ago. As we contemplate all of this, we are inevitably left with a question: what lies beyond the observable universe? The light from countless galaxies is simply too far away to reach us in any reasonable amount of time. And due to the constant expansion of space, many of these galaxies will never be visible to us. This means that there are regions of the universe that may forever remain out of our reach. Based on our understanding of physics, we estimate that the entire universe is at least 250 times larger than what we can observe. In fact, some experts argue that the universe could be infinitely large. This idea is both awe-inspiring and humbling. When we consider the universe's true size, we are reminded of how small we are in the grand scale of things, yet how deeply connected we are to this vast, mysterious cosmos. As human beings living on a tiny planet in a seemingly infinite universe, it's easy to feel insignificant. But when we pause and reflect on the beauty and enormity of it all, we come to realize that we are an essential part of the universe's story. We are inextricably connected to the stars, the galaxies, and the unimaginable forces that shape the cosmos. So have you ever wondered just how vast the universe truly is? If so, I hope this video has given you a deeper understanding of the incredible, mind-boggling expanse that surrounds us. If you have any questions or thoughts, feel free to share them in the comments. Don't forget to like, share, and subscribe to our channel so you can stay up to date on all the fascinating developments in space exploration. Thank you so much for watching, and I look forward to seeing you in the next video.